Hi guys, it's Miss Brown, and today we are going to talk about graphing simple inequalities. So, some things I need you to know is that when we are graphing an inequality, we are essentially identifying all values that make the inequality true. Let's focus on truth, that's important. And we're going to learn that to exclude means to leave it out or omit. To exclude a value, we use something called an open circle. An open circle just looks like this. It's just a circle, and notice it's not colored in. To include a value, we use a closed circle. A closed circle, again, is just a circle. We call it closed because we color the inside of the circle, which means we are including that number. So, again, let's focus on things that make our inequalities true. So I have an inequality that says W is greater than -1. I want us to think about what makes this true. Like if I said -5, right? Is -5 greater than -1? That's false. We wouldn't include that. Let me just grab something else, like this -2. If I ask you if -2 was greater than -1, that's false as well. Okay, well, what about 1? Is 1 greater than -1? That's true. So I know this value right here should be included. All right? Well, what about 0? Is 0 greater than -1? Yes, it is. That's true as well. Well, what about -1? Is -1 greater than -1? That's false. It's equal to -1, but it's not greater than. However, what about this number, say right here? This number could be, let's say, -0.9. Is -0.9 greater than -1? That's true. So, what I'm trying to get you to see is that 1 is our turning point. However, 1 is not included. Not 1, I'm sorry, -1. I apologize. -1 marks our turning point, but -1 is not included because -1 is equal to -1 but not greater than. However, all of this stuff over here, all of it is greater than -1. So what I would do is I would draw a line, and then on my line, I'm going to put an arrow. And that arrow symbolizes that my solutions go on forever. For instance, out here in the distance is 100. Well, is 100 greater than -1? That's true. Okay. So that is our graph. Our graph would be an open circle at -1 and an arrow going to the right. While I'm here, I need you to understand that this same inequality can be written in this form. -1 is less than W. I need you to know that those two inequalities, W is greater than -1 and -1 is less than W. mean exactly the same thing. All I did was flipped it around. Okay? So that's like me saying, if I told you, like, pretend I solved an equation and I told you x was equal to 1, and I flipped it around and said 1 is equal to x, it means the same thing. Okay? But we really have to be careful with our arrows. All right, moving on. So another inequality, x is less than 3. So let's think about values less than 3. And let's think about values that are not less than 3. I know that 5 is not less than 3. 4 is not less than 3. 3 is not less than 3. But wait a minute. 2, yes, that's less than 3. 1 is less than 3. 0 is less than 3. So our turning point is at this 2. Sorry, at the 3. So our question is, should we include the 3? Well, we said no, that 3 is not less than 3. However, for instance, if I wanted to put this number right here, okay, that number could be 2.75. 2.75. Let me write that again. It doesn't look like a 2.75. Maybe if I put it as a fraction. 2 3/4. That looks a little better. Okay, so is 2 3/4 less than 3? Yes, it is. So I don't want to include the 3, but I do want to include everything that is to the left of the 3. So I'm including all of this stuff here. Okay? And I'm putting an arrow to signify that my solution goes on forever and ever. All right, let's look at another one. We have y is greater than or equal to 0. So my question is let's just test. Is -5 greater than or equal to 0? Nope, that's false. And guys, these true false things, the F and the T's, you're not expected to write those, okay? I'm just helping you see how I think through it, all right? -4, that's false. That's not greater than or equal to 0. -3 is not greater than or equal to 0. -2 is not greater than or equal to 0. -1 is not greater than or equal to 0. But yes, 0 is greater than or equal to 0. So that qualifies. 1 is greater than or equal to 0. 2 is greater than or equal to 0. So this time, notice our turning point, if you will, is 0, but we do want to include 0 because 0 does make this inequality true. And then we want to draw an arrow going from that 0 and marking all the numbers on the right, because all the numbers on the right make that inequality true. Also, I want to point out that this inequality can be written like this. 0 is less than or equal to y. Those two inequalities are equivalent. I just flipped the inequality around. Okay, so the last one says z is less than or equal to -3. So what I would do is I would just think, okay, what are the values that are less than or equal to -3? So that would be things like -4 and -5, and even -3.5, -3.25. But do I want to include -3? And the answer is yes, because -3 is less than or equal to -3. And I also want to include all the values to the left because all of those values make my inequality true. Again, please note that this inequality can be written as -3 is greater than or equal to z. All right, thanks. Bye-bye.